this is a really long question. So, you know, in these kinds of questions, make sure to like read the question really carefully, especially this question, which is like really confusing. Make sure you understand it really well. So you have a finite sequence of 3-digit integers that has the property that the tens and units digit of each term are, respectively, the hundreds and tens digit of the next term. And the tens and units digit of the last term are, respectively, the hundreds and tens digit of the first term. So this is a really like confusing like sequence. Like it's kind of hard to understand what they're trying to talk about. So they give an example. They say, for example, such a sequence might begin with the terms 247, 475, and 756, and end with the term 824. Want to know, let S be the sum of all the terms in the sequence. Want to know what is the largest prime factor that always divides S. So let's first understand why their example works, right? They start with the numbers 247, 475, 756. What the question is saying, just in summary, what the question is saying is that these two digits here, 47, these are the tens and units digit of the first number. These two digits are going to form the hundreds and tens digit of the next number. So in this case, 47 over here, 47. Then you're going to look at like these two digits, 75. 75 are the tens and units digit of the second number. So they're going to be the hundreds and tens digit of the next number. So 75 appears here. And you basically continue this process. So basically the next term in the sequence has to begin with 5, 6 something, and so on. And eventually the sequence is going to eventually end at a term like 824, which works because the last two digits, 24, are the first two digits over here, 24. So that's basically what the question is saying. All those jumble of words is basically trying to describe this kind of sequence pattern. And we want to know, the question is like, if we take the sum of all the numbers in the list, what is the largest prime factor that will always divide S? So this is a pretty interesting question because they don't like give you what the sequence S is. They just say, if you write down any sequence S and you find the sum of the terms, what is the largest prime factor that always divides S? For these kinds of questions, like there is a rigorous way to do this. But like, suppose you did not see the rigorous way to do this, right? Like basically what you can do is you can kind of like check some special cases, because the question says, you have the answer choices 3, 7, 13, 37, 43. So basically the question is saying, no matter what sequence S we have, if we take the sum of those values, there's always going to be like prime factors that are factors of S, regardless of what the sum is. So if we just make up our own arbitrary sequence, right? So suppose we start out with a sequence like 2, 3, 5 or something. Then the next term in the sequence I can say is like 3, 5, 2. Then the next term in the sequence I could say is like 5, 2, 3. And this is actually a valid sequence, a sequence of 3 terms. And the reason this is valid is because the last two digits here, 3, 5, match these two digits here, 3, 5. The two digits here, 5, 2, match the two digits here, 5, 2. And the two digits here, 2, 3, match the digits here, 2, 3. So this, even though it's a really short sequence, this sequence still satisfies all the conditions that are listed in the problem. So in this case, if we were to add up these 3 values, S equals 235 plus 352 plus 523. If you were to do the addition, I'll just tell you, if you do the addition, you would get something like 1110. So if we were to prime factorize 1110, you can write this as 10 times 111. 10 is 2 times 5. 111 is 3 times 37. So we see that 2, 3, 5, and 37 are factors of 1110. So we look at our answer choices, right? The answer choices are 3, 7, 13, 37, 43. So let's write that down here. Our answer choices are 3, 7, 13, 37, 43. We can immediately eliminate 3 of the choices because we see that like when S is 1110, we have like 2 times 5 times 3 times 37. Clearly 7 is not a factor, 13 is not a factor, 43 is not a factor. So our only possible answers for this problem are either 3 or 37. And let's say in the real contest, right? Let's say if you were running low on time and you didn't really know which number it was going to be, you could remember the original question says, what is the largest prime factor that always divides S? So, it was pretty interesting how 37 was a divisor. So maybe if you're low on time and you're desperate for points, you would just put down 37 and move on, which would give you the right answer since 37 is the larger of the two primes. But if you want to prove this rigorously, the idea is to notice that, like, regardless of what sequence of numbers you have, right? Let's start with their sequence, like 2, 4, 7, like 4, 7, 5, 7, 5, 6, right? Suppose like the next term in the sequence was like 5, 6, 2 or something. And the last term in the sequence was 6, 2, 4, right? So this is like a longer sequence, but we notice that like it still satisfies all the possible conditions. So, right, because we have 4, 7 here, 4, 7 here, you have 7, 5 here, 7, 5 here, like you have 5, 6 here, 5, 6 here, you have 6, 2 here, 6, 2 here, and you have like 2, 4 here and 2, 4 here. So this is like just another like larger value or larger sequence of numbers. In this case, instead of 3 terms, you have 5 terms, and this will kind of help us like see a pattern, sort of, which is that like, notice that like, look at the number 2, right? You have 2 here, the digit 2 here, and the digit 2 here. Notice that like out of these 5 numbers, those are the only 3 places where the 2 occurs. It occurs in it occurs in the hundreds digit, the units digit, and the tens digit, exactly 1 time. If you look at the number 4 occurs there, it occurs there, and it occurs there. So it occurs in the tens digit, the hundreds digit, and the units digit. Again, it occurs exactly 3 times, 1 in each place. If you look at like the 7, you have 7 in the units digit, 7 in the tens digit, 7 in the hundreds digit. Those are the only places. Again, 7 appears exactly 3 times, 1 in each of the 3 places. And you can verify this for all the digits. They all appear exactly 1 time in the hundreds, in the tens, in the units digit. So if you call a digit, like you call the digit D, it's going to appear in the hundreds digit. So if you multiply that by 100, it's going to appear in the tens digit. Multiply that by 10. It's going to appear in the units digit. Multiply that by 1. So when you do the summation, the digit D is going to contribute a total sum of 111D. So notice that like 111, that looks very familiar, right? That is over here. So it turns out like 111 is going to be like a common factor out of all the digits. And 111, if you were to prime factorize that, you get 3 times 37, which is why 3 and 37 are always factors of the sum of the numbers in the sequence. So back to the original problem, if we wanted to find the largest possible prime factor, the answer would just be 37. And that would be like choice D.